a little bit more even challenging. So I want to make sure you understand where we are heading. All set? Okay. Number one, which was the question asked earlier. Now, how do I get for this second piece, or for the piece number one, how do I get the resultant L-fish force? The area happened to be the same, right? It's the same gauge. So now we are going back to what we did last lecture. So let me see if I can draw this somewhat separately. So now I have, for my purpose of analysis, I have now nothing but a remaining because the other pieces, the rectangle is already dealt with. Now I have a triangle of pressure distribution. Whereas on the base here, at the very bottom of this tank, what is the pressure? What's the pressure here? No, the pressure. It's rho GH. What's that H? When I ask that, you don't have to deal with the hinge and the gauge. You just ask yourself, I have a water tank of 2.1 meter. What is the base pressure? Anyone? 2.1. You have a problem with that? I mean, I don't see a lot of spark in your eyes. You just a lot of confused. Do you see that? Right? Because the hinge and the gauge being partially on the west side has no bearing. All I'm asking is I have this tank with 2.1 meter at the base. What's the pressure? Well, it's simply rho GH. Question on that? Okay. So in here, now that I have break up the pieces, the pressure on this side, what is the height? What is the height of this right angle triangle? 0.8, where do 0.8 meter? Such that the base pressure is rho G 0.8. Are you with me? So now I want to forget everything we have done so far, but just look at this pressure prism and go back to what we did last lecture. The last lecture. My pressure times an area. This pressure is an average pressure that I yet need to determine based on this right angle triangle. From last lecture, what's that average pressure? 0 at the top, rho G 0.8 at the bottom. That pressure will be 1/2 rho G 0.8. That's my average pressure. Question on that. Question on that. It's a little confusing because you look at it one piece at a time, and you have to keep that in mind to be successful in using this so-called superposition or Dirac and quantum. You have to logically break down the problem one component at a time in order to visualize this. Otherwise, it's hopeless. Yes?
Maybe not every problem, but I guess in this problem you could just as easily take like the pressure of the whole thing and just subtract the pressure of the top triangle and be left with
It's the same approach, what you said is equivalent to the same thing of what I did. Yeah. Yeah. The big roadmap is, we have now a rather awkward looking pressure distribution. There's not a triangle and it's not always uniform, it's a trapezoid. And to deal with that, the easy way to approach the problem is to break it up into two pieces. Okay? Can I go on? So the average pressure now is simply rho g 0.4. Well, where does the 0.4 come from? 0.8 divided by 2. And with that, the force, when you plug in all the numbers, is about 27,000 Newton. So that's one piece of the problem. Questions? Questions? Yes?
It says P average equals 26,700 newtons.
P average,
Like, what's the?
that's
pressure?
this. Only rho g
But it equals newtons?
is equal what?
But P,
Your units on P
but then
average.
it's not, it can't be a pressure that has units of newtons. I got it.
That's not, that's the force.
Oh, I'm sorry. This is the force. This is the average pressure. Only this term. Is that what you're asking?
Yeah.
Right, it's just poor label. Right, this is F1 plus F2. Okay, let me stop and make sure you're on top. Yes?
If that's F1 and F2 and we're combining them together, how are we gonna count that they're applied at different points?
Okay, so the question is the next step. Now that I'm done with the force, how do I get the moment? Is that what you're asking? That's the next step. But let's don't go that well yet until you're completely comfortable with what we have done. That's a little bit more complicated, right? But not that difficult. So are you on top? Are you comfortable with all what we have done? Piecewise? Yes?
Should we change the notations of some of this, because I don't think the reaction force, the force at the bottom of the.
Yes, thank you. Right. That's a very good comment. So let me call this, the force I'm calculating is actually equal and opposite to this. Thank you. Yeah, this reaction force is equal and opposite to the force that we calculated, max. Yeah, so this should be negative Fr. Yeah, this is the force due to the water acting on the gauge. Very good point. Yeah. Other questions? Other questions? So the next big step is now how do I deal with the moment? Let me do it here. So the moment will be taken about the hinge, which is 0.0. And like your homework before, it has to be 0. And now it consists of, first, that reaction force, which is Fr, times the moment arm. What's the moment arm? From the hinge to the reaction force at the base, what is the length? 0.8? That's the easy part. The hard part is now I have two forces, F1 and F2. And I would like to tackle them one at a time for the moment also. So I'm going to ask myself, what is the moment due to F1? I'll do that next. I'll do that last because it's more complicated. And what is the moment due to F2? Yes?
Should that be negative?
Which one? Oh, I haven't finished. I'm sorry. Yeah, that. I need. nomenclature for that. So the complete equation being zero, or better way to see this, just avoiding confusion. This is what I'm after. Does that make more sense? So I'm now then dealing with the issue of finding the moment arm for the force F1 and the moment arm for the force F2. Yes?
So can we say that force 1 plus force 2 equals Fr without the reaction forces at the hinge?
That's what we have done here, I think.
But we summed the force from the pressure of the triangle and from the pressure of the rectangle, and we just set that equivalent to the force that's keeping the hinge closed.
That's
but
correct.
Not the force, reaction force at the hinge, right?
I take this,
Like at point O, will we have reaction forces holding the hinge in place?
you mean at here?
Yeah.
Right there, yeah. Because if we already found Fr, then what's left to solve?
Yeah.
The moment.
But why do we need that?
It doesn't make sense.
Okay, I'm missing something, I'm sorry, I apologize. I'm trying to see what am I missing.
There would be reaction forces at the hinge, and that's why you use the moment.
So
Because
F1
we
is
can't
the
solve
equal-
it.
Fine, yes, sorry, yes.
So,
That's right, oh, boy, this, yeah, I get you all confused, I apologize. Yes, this is, whoa, right, yeah. So how should I correct myself? You're absolutely right.
The 26,700 doesn't equal negative Fr.
Yes, thank you, that's what I'm,
Yeah.
yes, thank you for that very important correction. Yes, there are reaction forces here that I have not drawn, and I don't know what they are, and I don't care, or F, X, F1. So absolutely correct. All this, so erase and start over. All I have done here is just to find out the forces due to the water. Right, thank you. And that resulted in this force in total due to the water. It's not the reaction force I'm trying to calculate. That will have to be done from the moment. Yes, thank you.
so that's your sum of forces due to both your applied hinge force and your reaction force at the pen.
No, this force as calculated is only due to the water,
Yeah.
period.
It would equal Fr, that's like that.
Okay, it's solely from the basis of this pressure distribution, nothing else. Had nothing to do with the reaction force. That was my fault, confusing. All have been done by all this step is the contribution due to the water, period. Okay? That was my mistake of confusing the whole lecture. So do you see that now? Do you see how it's corrected? Yes?
So you, with that force number, you could use that to solve the reaction force if you use the trapezoid centroid, right? Instead of
No, I can't get the reaction, I can't get this, not reaction force, I cannot get this external applied force, except using the moment. That's the only way. Because when I take the moment here, then the reaction force at the hinge disappears, just like you did for the homework today. Yes?
I think what he was saying is that you can take that combined force and use the trapezoid centroid to find, then treat that as one force instead of splitting up the two forces. Like you-
That is a lot harder.
Yeah.
If that's what you're asking, if that is the question, my answer is yes. But trying to find the centroid or trapezoid is not easy. It's a lot easier if you take the trapezoid, and that's what we're doing. Break it up into a rectangle, and then a right angle triangle. That's what we're trying to do. Yes, if you can find the centroid of the trapezoid, yeah, then what you say is correct. And you give the same answer. You have to. Okay, yes?
So why do you need the force due to water? Because essentially that doesn't really tell you anything without doing the moments.
That's the reason I need the moment. The only reason I get the force due to the water alone is just like you did for homework today, which I still have on the top, is because I need that to get my moment. How did you do this problem? You get the water force due to hydrostatic acting on this plate, and then you take moment about here, right? So step one is find out the force alone due to water. And that's what we did in the first step.
But if you know your F1 and F2 and those moment arms, then I'm saying does the water or the force due to water overall, the superpositioning of F1 and F2 actually tell you anything?
But that's what I'm doing now in this step. I'm just splitting them. Yes?
I think he's saying, well, what's the point of finding the sum of both?
What's the point of finding the sum of the moment?
No, the sum of
Just-
both the
just the
forces
sum of the
instead of the
forces. It was
individual
kind of-
forces.
Oh, I'm sorry, because the question asked you first for the force. Thank you. Yes. Right, I should have do a better job of stating the problem. There are two parts. So part A is find the force due to water. Yes, and then find the reaction. Sorry, yeah, not a good day. But I'm glad you asked all that clarification question. Right, so that was the reason. Yeah, you don't need it, but you still need F1 and F2. Am I correct? You still need F1 and F2. Yes. Yes. Thank you. So are we clear now? Too many sake bomb last night. Okay, where am I? So the challenge now, which is the finishing part, is to get the moment arm. Okay? For number 2, which is a triangle, which is a rectangle. Let me redraw a diagram to make it easier to follow. So I have now the uniform pressure distribution. We get the forces here of F2 already, as shown over there. My F2. So the force is rho g on 4 meter times the area times now a moment arm from the hinge, which is 0.0. No. This is F2, right? Yep. Anyone want to make a guess as to what that moment arm is for uniform pressure? Yes? Or you have a question?
I was gonna say, for point 2, isn't H 1.3, not point 4?
Yeah, I'm really getting my nomenclature mixed up, yes. Yes. Yep, I am somehow mixing my nomenclature in my notes. Thank you, yes, it's 1.3, yeah, my apology, yeah. I'm sorry, yeah, so what is that moment? 0.4, everyone agree? Anyone have a problem with that? Anyone problem with that? Now moving then to F1, I have rho g F1, so let me circle F1. It's this guy. So I'm just going to recopy that. Times an area. So now come the punchline. Now come the most critical question I want you to tell me. you have a right angle triangle. Let me draw that. No, this is not good to draw the hinge and gauge. All I want to show you is a right angle triangle. And I need to know the moment arm from this side. But prior to that, I want you to tell me for a triangular pressure prism, like we learned last lecture, where is that center of pressure, or where is that line of action based on a triangular pressure distribution? Yes? One third from the bottom, thank you. Thank you. That's what I want to hear, and I got it. So it's 1/3. I call it from bottom. Okay? 1/3 from the bottom, that's straightforward. Now from that, can you get me the moment arm? L1. What would that be? Something from the diagram? Is the O4 height minus, right? I want this length. So it's the overall height, which is 0.8 meter, minus 1/3 from the base. I'm making the problem more difficult than it looks because of my confusing setup. So I think from a big picture sense, those are the pieces. And it's really not that, I think, hopefully, difficult. But let me pause and make sure you have time to ask questions, if any. Is that clear? So if you do the math, you plug that in and do the take the moment arm, the reaction force, not reaction, the resultant external force applied at the bottom to hold the gate in equilibrium is about 14,000 newton. Questions? So I would like to use that as a backdrop to give you some hints on your homework.